Good morning, everyone. Welcome back. So today we're going to talk about some more advanced data structures today and next time that will allow you to put different types of data in the same structure. So if you think about the arrays that we've had up to this point, they were either numerical or they were text, but you couldn't mix the two. Well, now we're going to introduce some structures that will allow you to put different data types in a single array. And the one we're covering today is called a cell array. And next time we'll cover something called a struct or struct array. So these two statements, summarizing what these two different types of arrays are, probably don't mean a whole lot to you right now. Once you have had some experience with them, then you can refer to this and say, oh yeah, that makes a little more sense. But here's my explanation of the difference between a cell array and an ordinary numerical array or even a string array. A regular array you can think of as being like a fixed compartment box. Right? Every compartment is the same size. So if one has an integer in it, they all have to have integers. If one has a floating point number, they all have floating point numbers. If one has a character, they all have characters. A cell array is more like an adjustable compartment box, where the sizes of the compartments can be different. So you can have different things in different compartments. One can have a string, one can have a floating point number, one can have an integer, one can have a vector, one can have a matrix. So that's the really handy thing about cell arrays. You can actually put an array within the array. Okay, so it's just sort of a general purpose container. You can basically put anything in it. All right, so let's go look at the code examples and see how this works. Before I get to this, though, any questions about anything we covered previously? And I don't have any review questions today, so I'm not taking attendance. Why can't I find the chat? Oh, there it is. Okay. All right. So here's a really basic example of making a cell array and putting different data types in it. And so I have this thing I'm going to create called cell array 1, and I'm going to put, actually, let me clear the workspace. Still have all my stuff in it from yesterday. All right, so I'm going to put in this cell array 4 things. One is the number pi, which is a floating point number. One is the string Joe. One is a character array, ADC. And the last one is the integer 3. And so those are 4 different data types, and I'm putting them all in the same array. How do I know it's a cell array? Just from the notation. Notice here, instead of the normal square brackets, we have these curly braces. That's what makes it a cell array. All right, so I run it. You see now it's created. That cell array says it's a 2 by 2. The reason it's a 2 by 2, you'll notice I put a semicolon here. So just like with a numerical array, when you put a semicolon, that means go to the next row. And then to get information out of a cell, same thing, is similar to extracting from any other array, except again, you use the curly braces. And so this says, give me the contents of row 1, column 1, which is pi, and divide by 2. So I get pi over 2. Okay, so putting information into a cell array, getting it out, it's just like any other array, except you use a different notation with the curly braces. And then if you want to change the contents of an array, of a cell array, similar to a numerical array, you put the indexing now on the left-hand side of the equal sign. All right, so this is saying change the contents of row 2, column 1. So right now, row 2, column 1 is the character array, ADC. And I'm going to change it to be a row vector, 1, 2, 3. Okay, so now you can see I actually put an array within an array. And that's one of the handy capabilities of cell arrays. Now, one little subtle difference between the arrays we've covered previously and a cell array, I've shown this a couple of times, I think, that if you assign a value to one element of a numerical array, and you don't assign the previous elements to anything, they default to 0. All right, so up to this point, there is no such thing as row vector, and I haven't created it yet. And I'm saying set its third element to be 5. I didn't say anything about the first two elements, so they default to zeros. And similarly with a character vector. Okay, so there's no such vector yet, but I'm going to assign its fourth character to be a K. I didn't assign anything to the first three, so those will default to blanks. But with a cell array, it's a little different. So I have no such cell array yet as cell array 2, but I say set the third cell to have this column vector in it. I didn't put anything in the first two cells, so they are truly empty. Right? If you don't assign an element of a cell array to anything, it literally has nothing in it. It's in the language of other programming languages, it's a null pointer, because that's really what a cell is. It's just a pointer, which is why you can put anything in it, because it can point to anything. All right. Okay, so I have something in cell 3. Cells 1 and 2 are empty, but then I can come back and put something in those two cells as well. So I'm putting this row vector in cell 2, and I'm putting this character array in cell 1. Now, because you can put an array within the cell array, you can do a kind of double indexing. Like, let's go back and look at cell array 1 again. Okay, so this is what it has in it. Let's say I wanted to pull out one of the numbers from this row vector. Right, so I need to take this vector out of that cell, extract it, and then I need to extract one of the numbers from that row vector. And I can do that all in one step with double indexing like this. Okay, the first one says, give me the contents of cell row 2, column 1, which is that row vector, 1, 2, 3. And then the second one says, give me the second number in that row vector, which will be a 2. Or similarly with this one, what's in cell 1 of cell array 2? It's that character array, ENGR 1221. So extract that, and then give me the fourth character, which is the R. All right, so that's a convenient capability, since you often use cell arrays to store other arrays. It's convenient to be able to get things out of those arrays that are inside the cells in one step. Now, it's important, though, you have to get it in the right order. It has to be in this order. You have to put the cell indexing first, and then you put the ordinary indexing. So in other words, you have to access the whole numerical array first, and then tell it which element of that numerical array you want. Any questions about any of that so far? All right, one little subtlety that you have to be aware of, because this will bite you if you get this wrong. So every place up to this point where I've done indexing with a cell array, I've used the curly braces. Well, what would happen if you forgot to do that and you just put parentheses instead? It'll do something. It will not give you an error, but it won't do what you probably thought it was going to do. All it does is make a second reference to the same cell. Again, in the language of pointers, it just made a second pointer pointing to the same thing. But it didn't actually extract the information. And so what I was trying to do was extract the number pi from that cell. Okay, so I put row 1, column 1. But because I didn't put the curly braces, I just put parentheses, it did not do that. All it did was make another reference to that cell. So cell 1, 1 is just another cell array. It's a 1 by 1 cell array. and in its one cell is the number pi. But I cannot do this. Okay, I can't do arithmetic on it because I didn't take the number out of the cell yet. Okay, so I know that's a subtlety. It takes a while to get used to that. But the rule I'm going to give you is, with one exception that we're going to talk about next, when you're indexing with cell arrays, always use the curly braces. Okay. Now, what's the exception? The exception is when you want to delete one of the cells. And I'm teaching you this because you're going to need to do it on today's exercise and also on one of the application assignments. So I've shown you this before, where you can delete an element of an array by setting it equal to empty brackets. So you might think, I want to delete cell 3 from this array. So I set it equal to empty brackets. This will not do quite that. What this will do, it'll delete the contents of the cell, but the cell is still there. If you want to delete the entire cell, okay, so that this will then be a 1x2 cell array instead of a 1x3, that's when you use the parentheses. Okay, so that's the only time, for our purposes, when you're going to use parentheses with a cell array. That's when you're actually trying to delete the cell. So in today's exercise, for example, you're going to program a small part of a card game. And the way you're going to deal a card is you've been given a deck of cards that's in a cell array. You put it in the player's hand, and then you have to delete it from the deck. And this is how you're going to do that. Okay, this says delete that card, whichever position it is in the deck, delete it from the deck. Okay. All right, let's take 2 or 3 minutes to do a little example. So just make a cell array that has this information in it, your name, your GPA. Doesn't have to be your real GPA. It can be your aspirational GPA. Your major, the string ENGR, and a numerical array containing these 3 numbers. And then extract that information from that cell array and print out a message like this. So-and-so is majoring in such and such and is currently taking engineering 1221. He has a GPA of whatever.